with fintechs, government, and startups to build real-world solutions. So there's also opportunities for you as a developer, opportunity that you can explore. There's the Stellar Community Fund where you get up to 150,000 US dollars in XLM for promising project. It's open to anyone. There's also a Kickstarter program which is for early stage builders, and here you have access to funding of up to 15K USD in XLM, and you also have mentorship and technical help. There's also grants and bounties. So you, as a dev, you can also contribute to the open source tools and earn rewards. There's also hackathons, challenges that are hosted regularly, where you win real prizes, and you also get investor attention. So I'm part of the Stellar Ambassador Program. For those who are interested in coding and learning, I advise you to learn the Stellar Ambassador Program. I think I'm gonna send all the details tomorrow. So the benefit of joining, you'll be part of a global network of builders and advocates. You'll get access to resources, event support, mentoring, and early opportunities. So if you have the talent of teaching, or if you are a very good speaker, or if you are maybe a graphic designer, is so good in graphic designing, or anything that you can do to help build the ecosystem, you are welcome, and use your skills to grow the ecosystem. So this one is an example of what I'm doing here. Is just one example of what a Stellar Ambassador can do. So this is what you can expect as a decentralized app developer. So these are some realistic expectations for you. So you're gonna be learning Rust and Soroban SDK. So Soroban SDK is a smart contract tool that is used to create smart contract on Stellar, and you'll build real world solution with real assets, tokens, stablecoins, etc. You'll understand how to deploy, test, and interact with contracts using front-end tools. You also contribute to open source and collaborate with a mission-driven dev community. And there's also opportunity to turn your side project into a funded business. So why build on Stellar? We're gonna get deeper into that, but it's just an overview. So real-world utility, like in payment, in identity and remittances. Stellar is also fast as a blockchain. Is fast. It also has cheap transactions. It's a growing ecosystem. It's backed by major organizations, government, and also infrastructure. There's easy onboarding for developers and users. And one thing I'll also tell you is how far you go with it is up to you. Okay. Any question? Anybody has a question? You can raise your hand if you. Okay. Mukta, you have a question?
Oh, sorry, my hand was still raised from earlier.
Okay,
but I do want to find out, are you going to be sharing the like slides and everything with us as well?
Yes, I will. I will be sharing slides.
Excellent, thanks.
Okay, Costa. So everyone who raised hand, can you please unraise hand?
Okay, Ben, it's okay. It's okay. It's okay, Ben. I just want to quickly confirm that the ambassador program, if you're an ambassador, you are not limited to only being a teacher, a graphic designer. You can do quite a lot, or you are limited. Say you're coming into an ambassador, you can just be a teacher or a graphic designer or something else, or a developer.
No, you're not limited.
You're not limited.
Yeah, it's up to you. It's up to you to be as creative as you can. It's also up to your vision. What you see can be done to grow the ecosystem. So if you have anything that you have in mind to grow the ecosystem, you can write a proposal and send it to, if you like, here in Southern Africa, we have a president. So you write your proposal, you send it to the president, and it's going to approve. It's up to them to approve or disapprove of your proposal. So that's how it works. but
Okay.
you need to join the group. I'm gonna send the details tomorrow. All the details tomorrow.
Yeah, I'm in the Stellar group, the WhatsApp group already. So I
Okay.
just want to, okay, another one last more question is, let's say that I want to do an offline event. I'm based in South Africa, but I'm originally from Zim, right?
Yeah.
And I want to do an offline event for my community that is back home in Zim so that they can understand crypto, because I know they're still a little bit behind, but
Yeah.
I want them to understand crypto. Is there any help that will be added on Stellar so that I can teach people to understand crypto as offline events back home or here in South Africa?
Yes, you can also do it because the Stellar, this side we're dealing with the Stellar Southern Africa, so it also includes Zimbabwe. So yes, if you have any idea, just drop that idea, send it to us. You can send it to me in the group. I don't know if you know Yaliwe.
Yeah, Yaliwe, yes, I know. I met her once in Johannesburg, but we didn't talk much. But I think I'll message you or I'll message you. Then we take it from there so that we can start to we can do the offline events here in South Africa. Anyway, we are flexible in traveling. I can travel anyway so that we'll be able to teach about Stellar.
Yeah.
Okay, no problem. Thanks, Ben.
Yeah, thank you. Okay, someone also joined. Hello, Sipo. Okay, so far, any other questions? Yes, there's no question. Okay, we're gonna jump into our presentation. So before we get our hands dirty into coding, learning how to code and all that, and by the way, it's going to be beginner friendly. Before we get into that, I want everyone to have an understanding of what is blockchain. So this is what we're going to start. So the first slides is just going to be the introduction of blockchain, and then after that, I'm going to speak about the Stellar stack, and then from Stellar stack, we're going to be learning about the consensus mechanism. So after when we have all that sorted, we'll get into coding. So I want to go as fast as possible, but not too fast, because I want everyone to understand, to have an understanding of what is blockchain and the Stellar stack. So in this slide, this is what we're going to cover. What is blockchain, the history and evolution of blockchain, and then how blockchain works, the core concept, the decentralization, consensus, and smart contracts. These are very important concepts that you have to know. And you also have to know why it matters, and then some of the use cases, the overview of different blockchains, and then we'll jump into blockchain in action. Okay, so what is blockchain? This is a very, very important question, and people have different way of explaining what is blockchain. I also advise you to also, like, after this session, you can also make some research to just have a deeper understanding. But we're going to use an analogy here to explain what is blockchain. So imagine a record book that isn't owned by any single person, but is shared across thousands of people on a network. In fact, there are 10,000 identical copies of this record book. So whenever someone adds a new entry, it's automatically updated across all copies at the same time. So in this way, everyone always sees the same information, and no one can secretly change anything without others noticing. So now there's 10,000, imagine a record book. So no one owns that record book, but it's shared across thousands of people. So when you add a new entry, all that happens automatically to every other notebooks. So if someone tried to secretly change anything without others noticing, then it's not going to work. So you can see it as a shared notebook that works as follow. So we call each page a block. Like in blockchain, the block. So each page is a block. So every new page in the notebook, every new page in people coming late. Okay. Every new page in the notebook records a list of transactions or data. So pages are also linked together. So once a page is added, it's permanent. You can't erase it or change it. Only add new pages if needed. And then the other thing that also is very important about this notebook or this blockchain is everyone must agree. Before a new page is added, everyone must check and approve the content. So this is the idea behind consensus. So everyone is a copy. The notebook exists in thousands of identical copies across the network. So any attempt to cheat is easily noticeable and it's also rejected. So another thing about this record book or blockchain, it's secure and transparent because it's shared and unchangeable, and everyone can trust the notebook without needing a central authority. So blockchain is like a digital notebook that's shared, verified by everyone. It's tamper-proof, and it grows one page or a block at a time. So if you fully don't understand this concept yet, don't worry, because I'm going to be repeating it over and over again until it sticks. So in definition, a blockchain is a decentralized distributed ledger that records transactions across many computers in such a way that the registered transaction cannot be altered retroactively. So the way blockchain works, it runs on multiple computers all around the world. So let's say there's some computers in South Africa, some computers in India, some computers in the US, some computers, like they're all over the world. So every computer have a copy of the ledger. So the ledger is like the page, all the transactions in the page. So they all have a copy of that. So if you want to change something, all the computers have to be noticed about it. And all the computers have to agree before there's some changes. So this can be like a transaction. For example, if I send you Bitcoin, for example, the system is going to verify that, okay, this transaction is valid, it's going to the right person. And in one way, this is also going to avoid double spending, and nobody can say, oh, you didn't send me money, because there's proof. You didn't send me the Bitcoin because there's proof. All the transactions are open to everyone to view. It's transparent. And here's the key characteristics of blockchain. The first characteristic is the decentralization. So there's no single point of control. Multiple participants maintain the ledger. So these participants are like computers, or also known as the nodes. So they maintain the ledger. And there is transparency. So all participants can view the transaction recorded on the blockchain. So everything that is done in the blockchain is viewable. But of course, they're not going to know your name. So you just an address. If you use, for example, Bitcoin, you have your address, you have your public key, you have private key. So everybody can see your public key, and they can see all the transactions through that public key. And another characteristic is immutability. So once recorded, transactions cannot be altered or deleted. This is the essence of blockchain. Transactions like financial exchanges or data transfers are recorded in blocks and then chained together chronologically. Any question so far? Okay, let's move on. If you have a question, you raise your hand. So let's move on. So here's the history and evolution of blockchain. So the first concept of cryptographic chains was proposed by a few scientists in 1991. And then in 2008, there was a person called Satoshi Nakamoto. We don't actually know that person. Maybe it's a group of people. Nobody's sure. So they proposed a white paper of Bitcoin, and then they released it in 2009. So the first transactions were started into the first Bitcoin transaction started in 2009. And here are the milestones. The first Bitcoin purchase of a real asset, we can say real product, was in 2010 when someone spent 10,000 Bitcoin to purchase 2 pizzas. So that 10,000 Bitcoin now is equivalent to 10,000 times 100,000. So it's in billions now. And from 2011, there was an emergence of alternative cryptocurrency like XLM, Ethereum, and so on and so forth. So from 2011 and up, there was many other crypto projects that became widespread. In 2015, a new special blockchain was launched called Ethereum. So instead of dealing with crypto, or it launched a programmable smart contract. So now crypto could not just be used just to send money in cryptocurrency, but now you can actually create a smart contract on top of a blockchain. And then in the 2020s, there was rise of DeFi, decentralized finance, NFTs, not fungible tokens. And I don't know if you've been in crypto, if you've been buying crypto, dealing with crypto, like since the 2016 or 2019, you'll have heard about NFTs. So it was crazy. It was really, really crazy. And so and the milestones, in 2017, there was an ICO boom, and which created a widespread interest of blockchain. So the ICO was the initial coin offering, where someone created a coin and say, okay, we've created this cryptocurrency. These are the utilities. You can do this. You can use it for that. And then people invest in that new blockchain project. So a lot of people made money and a lot of people lost money. So it was just part of the game. In 2024, we have almost 10% of the world population. So 560 million crypto users worldwide, which is actually it's like 6%, I think, worldwide, which is good. It's a good look. So and I'd say we're still in the beginning phase of blockchain and cryptocurrency, because it's not even 15 years yet. Yeah, it's 15, 16 years, which is relatively young compared to other technologies. Any questions so far? Okay, we're moving on. Okay, now we're getting to the meat, more information about how blockchain works. So again, here we're thinking of blockchain as a record book. So think of each block as a page in the record book. It holds transaction details and a unique code called the cryptographic hash. That cryptographic hash is like a fingerprint. And this code is linked to the code of the previous block, creating a chain. So the importance of cryptographic hash is to make the whole blockchain to be consistent. So any changes, if someone could be able to make some changes in a block, then the cryptographic hash won't make sense and the whole chain will be invalid. I don't know if it makes sense. Excuse me. Some more people are joining. So the cryptographic hash, I'd say, is something that maintain. It's like the glue to make sure that everything is consistent. So if the cryptographic, if you make any changes, if it's possible for you to make any changes, then you're just gonna spoil everything. But of course, that never happens because in order, the first step to do that is you have to do what we call the 51% attack, meaning that you have to attack close to 51% of all the nodes in the network in order to make some changes, which is highly unlikely. So, and there's two parts of a blockchain. There's a header, and then there's a transaction. So the header contains metadata such as the previous block hash, the time spent, the time stamp, and the nonce. And then there's also a transaction, which is a list of all transactions included in the block. I think there's something that I'm going to show you to illustrate how it works. I'm gonna show it to you tomorrow just to illustrate how cryptographic hash work, how it works in action, maybe so that you'll better understand what I'm trying to convey to you. So there's the block structure as a header, which has the metadata, such as the previous block hash, the time spent, and the nonce. And there's a transaction, which are the list of all transactions included in the block. There are storage and linking. So each block references the hash of the previous block, forming a chain. So this ensures that altering a single block would require altering all subsequent blocks, making tampering difficult. Like I said, the cryptographic hash is there to ensure that you can't make changes, because if you alter a block, then the whole chain will be invalid. Won't make sense. Any questions so far? If you have any question, you can interrupt me by raising your hand as we're going through the slides. Don't be shy. Okay, so here are some terminology that you need to know. One of the most important one, as a smart contract dev, you need to understand what is a smart contract. Smart contract is a self-executing contract with the terms directly written into code. So I'd say it's like an app that has a law written on it, law and instruction that has to be applied, that you cannot change. And so once you deploy your smart contract on a blockchain, you won't be able to change it. But there's a way. Of course, if you're in the space, if you've been in the blockchain space for a long time, you also understand that there's such a thing as upgradable smart contract. But that's another story for another day. But in principle, a smart contract cannot be changed. Excuse me. And another terminology that you need to know is a wallet. So a wallet is a digital tool that allows users to store and manage their cryptocurrencies. So that's where you store your cryptocurrency. The wallet is also used for you to send transactions. It has what we call the private key and the public key. The private key is what you keep for yourself. If somebody steals your private key, then they can use all your funds. They can do whatever they want to do with your fund. You also have a public key. The public key is the address that is visible to anybody. So if you want someone to send you some crypto, you send them your public key for them to send you crypto. And then there's a node, another important terminology. So a node is a computer that participates in the blockchain network. And there's a ledger. A ledger is a record of all transactions on the blockchain. And something I'm going to be talking about, consensus. So consensus is just the process by which nodes agree on the validity of transactions. So I have a whole slide that talks about it and how it works with Stellar blockchain. And another thing you have to understand is the hash. So a hash is a cryptographic function that converts input data into a fixed length string. So I'm going to show you in action tomorrow. Yeah, let's move on to decentralization. Okay, so what is decentralization? Decentralization means that control is distributed across multiple participants rather than being decentralized in a single entirety. Before okay, somebody join us right now. Okay, before even appreciating decentralization, you also need to know what exactly is centralization. So I'm going to give you an example of centralization. Let's say a bank. A bank is centralized, both in principle and also in the technology that they use. A bank is centralized, meaning that they keep all your information. They have all your transactions. So when you use your bank app, you can see all your transactions. You can see all your private information, and so on and so forth. So let's say a bank has a server and 4 backup servers, right? And then somebody, a smart person, finds out where all those servers are located and decides to destroy all those servers. So this means that all the information that you have is gone. And this means that there's going to be chaos. Because can you imagine, let's say you have $10,000 in your bank account, someone has $100,000, another person has 2 million, another person has 50,000. And then one day, all that information just disappears. It's going to be chaos. So nobody will know. Nobody will have proof to say, okay, this is how much I own. And another thing about centralized entirety is there's always that potential for bad actors. And things like that happens a lot in SA, where someone who works in the bank can monitor all your transactions and then figure out that, this person might be deceased. This bank account hasn't been active for like 10 years. So let me steal this money. So things like that can happen because it's centralized. And also in 2008, there was a recession that was caused by there was lack of trust of financial institution. So apparently financial institutions were mismanaging people's fund. So imagine you have your insurance and then you've been paying for the past 20 years in your insurance, and then you just found out that all that money was stolen. So we can't really fully trust centralized entirety or centralized organization. So that's why we can actually see that decentralized is one way it's one of the way to solve this problem. We can actually appreciate decentralization. So decentralization means that control is distributed across multiple participants rather than being centralized in a single entirety. So the importance of decentralization in blockchain is it increases security by reducing single point of failure. It enhances transparency and trust among participants. It promotes resilience and resistance to censorship. So another thing with decentralization, there's no censorship. So I can't block your wallet. Unlike banks, With banks, bank can decide to block you from using your bank account. They can freeze your bank account. But with blockchain, doesn't happen. So unlike traditional systems with central authority like bank, blockchain is decentralized. Every computer on the network has a copy of the ledger. So this eliminates the risk of a single point of failure and reduces reliance on third parties, potentially lowering transaction cost. So for the newbies, who haven't dabbled into crypto, something else you have to understand about cryptocurrency is you are the bank. When you use cryptocurrency, you are the bank. You are in charge of your cryptocurrency. So if you lose your private key, your money is gone. There's no customer service. There's no one that you can call to help you recover your funds, because it's decentralized, and essentially you are your own bank. So that's something that you should know about having a decentralized wallet. So far, any question? So if you have any question, you can raise your hand. Feel free. I want to make sure that everyone understands. So everyone is in the same page. Okay, so let's move on. Consensus mechanism. So this is just an overview of a consensus mechanism. We'll dig in deeper later on. So a consensus mechanism is a process used by blockchain networks to achieve agreement on the state of the ledger. So the importance of consensus mechanism is to ensure that all participants agree on a single version of truth, maintaining the integrity and security of the blockchain. So here are the types of consensus mechanism, because we have like thousands or maybe hundreds of different blockchains, and all of them have their own consensus mechanism. So these are the most popular one that we know of. It's proof of work. So this requires nodes or computers or miners to solve complex mathematical problems to validate transaction and create new blocks. This is used by cryptocurrency like Bitcoin. But the downside of proof of work is it's very power intensive. As the mathematical problem becomes harder and harder, more and more difficult, it becomes more and more power intensive to solve those problems. Where else back in the days, if you were mining Bitcoin, let's say in 2009 or 2010 or 2011, it wasn't so power intensive as it is now. So another type of consensus mechanism is a proof of stake. So here, validators are chosen based on the number of coins they hold and are willing to stake as collateral. This is used by cryptocurrencies like blockchain, like Ethereum 2.0. So Mohammed, can I ask?
Yes. Why the amount of power increased? Because of the number of transactions, or what the reason?
So the mathematical problem. So as the value of Bitcoin increased, as more people get into it, because once you mine Bitcoin, you get incentives. You get fractions of Bitcoin, right? So
yes.
So now, back in the days, since there was not a lot of people there were a few people who were in the network, so it was much more easier for people to mine it, and even the incentive was even higher. So you were getting more Bitcoin back in the days for mining. But as more computers are joining, more nodes are joining, there's like a competition, because essentially for you to validate a transaction, for example, there is like a competition among many computers. So someone will say, let's say I was using a computer that maybe the CPU was like 2 gigahertz, for example. Back in the days, I could mine easily with 2 gigahertz, a laptop that is 2 gigahertz CPU. And then another person say, you know what, I can use a GPU. And then it goes inside the network and start mining So essentially now he's going to be the one who's going to be getting all those coins because he saw that his computers will solve the mathematical problem the quickest. Does it make sense? So now other people will join the network with more and more powerful computers. So it becomes like a competition of, okay, I'm going to come with my powerful computer. I'll come with my powerful computer. And what? So now, as more powerful computers are joining the network, the mathematical problem just keeps getting harder and harder. And because it's harder and it has to process all those problems using your computer, using your whatever machine that you're using, then that uses a lot of power. I don't know if it makes sense.
Yes, makes sense. Thank you.
And then there's also proof of stake. So proof of stake, you essentially just, let's say you have 32 Ethereum, for example. I have 32 Ethereum, and I want to be a validator. So I'll put my 32 Ethereum, I stake it somewhere. So I can't remove it. I stake it somewhere, and then I validate transactions. So if I become a bad actor, if I'm not honest, then I'm going to lose my coins. I'm going to lose the coin that I staked. So this collateral I use, this staking is used to incentivize miners, validators from cheating the system. I don't know if that makes sense. So Ethereum used to use proof of work, but then they changed and then started using proof of stake because they realized that proof of work was just so power intensive. They figured that, okay, let's see if we can change our consensus mechanism, and all this doesn't happen by a single person. So it's a group of people. It's open source. So they're like, okay, we're gonna do this. So all the nodes have to agree. All the nodes have to agree to those changes. But there's also other instances where they can be like a coin like Ethereum, for example. Ethereum is open source. So let's say they want to upgrade Ethereum to use another protocol, for example. Let's just say in theory, let's say 40% or 45% of nodes don't agree. They don't agree to those changes. Then there's something that they call forking. So a couple of nodes, maybe one set of nodes, maybe like 45% of nodes will say, okay, we won't change. We want to stay the same. We don't want to change anything. We don't want to upgrade. And then they gonna fork. So the chain now will be like a fork. Can you just imagine like a fork? A fork is like different. It's like two different things pointing different direction. So one fork will decide to move their own way, and the other one will decide to move their own way if whatever upgrade they decided to do. So this is something that happens. It happens in the blockchain world. And then there's delegated proof of stake, where participants vote for a small number of delegates to validate transactions and create new blocks. So they really have to trust those number of delegates, or else it won't work. And then there's Byzantine fault tolerance. This is what is used in Hyperledger Fabric. So this ensures that the system can continue to function correctly, even if some nodes act maliciously. So this is an overview of consensus mechanism. We're gonna delve deeper into it later on. So if you don't really grasp it right now, don't worry. I promise you're gonna know by the third slides that I'm going to share. So here are the benefits of blockchain technology. First is transparency. So all transactions are recorded on a public ledger, and it can be audited by anyone. There is security. Uses advanced cryptographic techniques to protect data integrity and prevent tampering. There's efficiency. It automates processes and reduces the need of intermediaries, lowering cost and speeding up transactions. Yeah, you don't need banks. You don't need anybody to be cutting your fees. You understand? So it's very efficient, and there's traceability. So it provides a clear record of the origin and the journey of assets, useful for supply chain management. I know some people, when it comes to fiat currency, so fiat currency is like the dollar or the rand or the rupees. So some people say that cryptocurrency is more like, it's more dangerous. Criminals can use cryptocurrency for illicit means. So it's better to use fiat currency than cryptocurrency, because cryptocurrency is much more dangerous. But what you don't understand is with cryptocurrency, there's traceability. With fiat currency, you can't really trace where the money is going. Somebody can withdraw money from the bank account and then put it in another bank account. You won't really know that, this money came from here and then it went there. There's no traceability. But with cryptocurrency, I'd say it's much more easy to track bad actors or people who use crypto for illicit means, because by the time those people want to use tools to off-ramp the cryptocurrency, then you'll say, okay, this crypto came from this, it went from this address to this address, from this address it went to this centralized exchange, and then from this centralized exchange they can contact this centralized exchange that, hey, blacklist this address, or blacklist this cryptocurrency coming from this set of address. So I'd say cryptocurrency is much more, it's a better system than fiat currency when it comes to crime, protecting people from crime, criminal activities. But of course, this is debatable. It's debatable. So here's the challenges and limitation of blockchain. First challenge is scalability. There's difficulty in handling a large number of transactions quickly. Energy consumption. So this is not for every blockchain. So some blockchain, like for proof of work, there's high energy consumption, and there's regulatory uncertainty. There's lack of clear regulation in many jurisdictions, and adoption. So there's resistance from traditional institutions, and there's also a need for technical expertise. So this is where you're at. We need people who have that technical expertise, and we're also here to grow the adoption of cryptocurrency in our communities. So far, if you have any question, just raise your hand. I'll be moving on. So now, the use cases of blockchain technology. So we know, a lot of us know cryptocurrency, Bitcoin, Ethereum, and other digital currency. So people use this currency for doing transactions. I can buy a house. People have sold houses, bought cars using cryptocurrency. Even here in SA, we have there's a supermarket shop called Pick and Pay that allow people to actually buy goods using cryptocurrency. So there's a light, or the mass adoption is growing. And it can also be used for supply chain management, enhancing transparency and traceability of goods. And it can also be used in healthcare, securely storing patient records and ensuring data privacy. It can also use on finance, streamlining cross-border payments and reducing fraud. And also voting, especially voting. I think a lot of countries have to start implementing blockchain for voting, because it provides secure, transparent, and a tamper-proof voting system. So you as a dev, you are needed to build all these applications. So that's why I think if you're in this journey like me, you're in the right track. So now this is the overview of major blockchain platform. We have Bitcoin. So this was the first and most well-known cryptocurrency, primarily used as digital gold. And we have Ethereum, a decentralized platform that runs smart contracts and decentralized application. And we have Stellar. So Stellar focuses on facilitating cross-border payments and remittances. And there's Hyperledger. It's Hyperledger. It's an open source collaborative effort to advance cross-industry blockchain technology. And there's also Cardano, a blockchain platform focused on sustainability and scalability. So these are just some of the major blockchain platform, and all of them have different use cases. They also have their focus, their main focus. With Stellar, their main focus is facilitating cross-border payments and also making payment as easy as sending an email to somebody. So they really focus on that, and especially in emerging economies like Southern America, Africa, and Asia. So here's a quick overview of Bitcoin, because I don't want to just talk about Stellar. I want you also to have an understanding of other blockchain platform that we have. So Bitcoin is a decentralized digital currency that operates without a central authority. I think this is the most popular one. The key feature is it uses proof of work consensus mechanism. It has limited supply of 21 million Bitcoins, and the transactions are pseudonymous and secure. So the use cases: digital payment, store value, remittances. But I wouldn't say remittances that much, but digital payments and store value mostly. Okay, now we move on to Ethereum. You know what? I'm gonna stop here because I want to respect your time. But if you have any question before we leave, you can shoot it. And tomorrow, okay, Day, you can ask a question.
Yeah. Okay. Thank you, Ben, for the session. Very good, informative session. Thank you. I just have a quick question. It's a general question. It's not like from what we have covered today.
Yeah.
I want to know what makes Stellar better than the other blockchains, and does it have any advantages over other blockchains in respect of? I know Stellar has got a lot of regulatory compliance, and it's got many partners, well-established entities like Visa. For example, let's look at Solana. Solana can do many transactions per second. The maximum is about 65K. So generally, it can do like 3,000 to 4,000 transactions per second. And we've got something like a BNB. BNB has got low gas fees. Right. So my question is, what can make someone want to learn how to develop on Stellar, and also other blockchain developers? Why would they prefer to use Stellar blockchain to do their development compared to other blockchains?
Okay, very, very good question. Of course, there are many different blockchains, and they all have their strengths and weaknesses. Like Solana, for example, is a very prominent one. So I wouldn't say one is better than the other. I will say that it's all about the vision. You know, every blockchain has a vision. And if that vision resonates with you, maybe that vision resonates with you. Like in Stellar, in the case of Stellar, is they're focusing a lot in emerging countries. So they have a lot of partnership with institutions that works, financial institutions that work in those emerging countries, and also work with government in those emerging countries. So they can do similar things like other blockchain. Like for example, I'll say Stellar could work similarly like Solana, for example. But I'm not too versed on the whole ecosystem of Solana, so I can't really talk about them in terms of where they really focus on. But the killer for me, I can tell from my personal experience why I'm here in Stellar is, okay, we can talk about low fees. We know it has low transaction fees. It is fast. It is efficient. We can talk about that, but what do they stand for? So they're standing for giving access to everyone to financial system, especially in emerging countries, and they also offer a lot of opportunities to people who are building solutions, like developers, like you, for example. They have mentorship. You know, it's a community. You know, I love the community, and they do a lot to encourage you to grow in the ecosystem. And I don't know if you've worked with Yaliwe. You know, Yaliwe, for example, she's the president of Stellar Development Fund, the Stellar ambassadors here in the Southern Africa. So she always encourages us, you know, to push ourselves. She always encourages us to learn, you know, and it's just one of those vehicles that you can select as a developer, you know, to grow yourself. So that's all I can say. I don't know if you resonate.
Yeah, no, I understand very well. Thank you very much. Yeah.
Okay, guys, I don't want to steal your time. So tomorrow, same time. So it's going to 2 times a week, Monday, Tuesday, 7 to 8.
Okay.
Mukta, yes, you can shoot that question.
Oh, okay, yeah. So now just confirming, because on my calendar it's only for today. Is there another link for tomorrow?
Yes.
It's basically every Monday that's on my calendar, not Monday and Tuesday.
Okay, I'm not trying to fix it. Yeah, I'm not sure. Yeah. I'm not. But it's the same link. Yes, same link. Monday, Tuesday, okay, same cool. Link. Yeah.
Cool.
So tomorrow we're just gonna cover the rest of everything about blockchain, and then we jump into Stellar Tech. So thank you, everyone, and also write your questions. If you have any questions that you didn't ask, you can write them down for tomorrow. And yeah, have a wonderful night. Goodbye.
Thanks a lot. Appreciate you. Night, guys.
Thank you very much. Good night, guys.
Thank you, Ben.
Good night, everybody. Thanks, Ben.
Good night.